JAMB 2020. Let's take this question on dimensional units. Which of the following is the dimension of pressure? So first, let's avoid confusion in things that has to do with units, because basically unit is physics. So take for instance, if you are to measure a length, the SI unit of any form of length, whether you call it a height or you call it a distance, or you call it height, call it distance, call it length, call it breadth, whatever you call it, so far is just from one position, a straight line position, or whatever kind of line position. So length, the unit for length is meter. That's the SI unit for length. And then the dimensional unit, that means at the core basic of it, what is actually the unit of length is a length. Take for instance the dimensional, you might see that we might have height, you have distance, you have displacement. All those language, their units are the same, and their dimensional unit is what? Length, L, represented with capital letter L. So if you take a quantity, derived quantity like area, area is length times breadth. But at the core point, this is length times what? Another length. So the dimensional unit of area is what? L squared, capital L squared, length times another length. You understand? So that's what we mean by dimensional unit. So now, which of the following is the dimension of pressure? Before you're able to determine the dimension of pressure, first you have to be able to define pressure mathematically. Pressure is defined as the ratio of force per unit what? Area. So pressure is talking about the amount of force you exert on a certain area. This is the area and this is the force. So that's the definition of pressure. So how much force do you exert on an area? That defines pressure. So what pressure has so many units, but at the fundamental form, the unit of force is what? Newton, and the unit of area is what? The unit of area is meter square. So the unit of pressure is what? Newton per meter square. But the question here is we should find the dimension of pressure. That's the dimensional unit. So this is the SI unit of pressure. So we are now to look for what? The dimensional unit. So that means at the core or the very foundation of this quantity, pressure, what are the fundamental quantities involved? At the core foundation of units, what we have is mass, length, and time. This is the three basic. Though recently they've added capital letter I, which is current. So this is but the three basic dimensional unit is what? Mass, length, and time. That means every other unit that you think of contains these three units. So now let's find the dimensional unit of pressure. So now, first we have to find out of force. Force is defined as what? Mass times acceleration. Then divided by area. Area is defined as what? A length times another length. A length times another length. So if we continue to split that, so mass, the dimensional unit of mass is capital letter M. Capital letter M represents what? Mass. So we've written it down there, times. If you break down acceleration, the definition of acceleration is what? Velocity over time. Then remember, over what? Length times length. That's L raised to the power of 2. Now, if you split this velocity into its dimensional unit, this is mass. Velocity is defined as displacement over time, and displacement is a length. So that's like saying a length over time, over another time, then over L squared. Hope I'm not getting anyone confused or making it cumbersome. So this will now be mass times, if you process this, you will have length divided by time squared, then divided by L squared, which is the same thing as here, m times length divided by L squared times t squared. This is mathematics. I also have videos on processing fractions on math. So this L here will cancel one of the L. You know, there are L times L here. So this one of this L will cancel one of it. So you are now left with L m divided by L times t squared, which is the same thing as m. If you bring L to the numerator, that will be L raised to the power of minus 1. And if you bring t squared to the numerator, that will be t raised to the power of minus 2. So the dimensional unit of pressure equals to m L minus 1 t minus 2. So what option is that? Option A. Option A. Thank you.